It's 2 hours UTC, and it's time again for Astronomy Daily Live. So, hey, everybody, look, the hardware is working today. Amazing. Just absolutely amazing. So thanks again to Uncle Bill for giving some assistance there, and yeah, making this all go. You'll regret that, Uncle Bill. You'll regret making this all go. So, cheers. I've got the, I actually have the dihydrogen monoxide tonight because it's, it just sort of seemed appropriate, and yeah, it'll keep me awake a little bit. So, cheers. So, Astronomy Daily Live is just a daily live stream where an ever-growing number of us come together and just share a passion for the science of astronomy, and doing our best to both understanding and appreciating the universe. And I sort of have sort of three pillars that I sort of utilize. The first is curiosity, and not everybody is curious. There's a lot of people who just sort of accept things. It's just like, okay, the sky is blue, like far out. That's all I need to know. But there are others, and I think they're all participants in this live stream. We do have a curiosity. I'm gonna pop open my chat while I'm ranting here a little bit. So Tom is in the chat. Atta's in the chat again. Hey, nice to see you. Cool. Thanks for the link, Bobby. That is great.
Not a problem.
Cool. So curiosity is sort of a motivator, right? That's, it's like, okay, the sky is blue, but it's like, why? Why isn't it black? Why isn't it yellow? Why isn't it, why does it have to be that tone of blue? And is it always that tone of, the questions, when one is curious, the questions just keep coming. Just it's like an avalanche, right? It's like you start with one, and then it's like, just this explosion. And that is curiosity. The other pillar that I like to stand on is skepticism. So, when I make an observation or I hear something that somebody has told me, I'm my first reaction, right? Even if it's my own observation, right, is to doubt that, is to say, it's like, is that really what's going on here? Is there something else? That. And then the third pillar that I like to stand on is open-mindedness. So open to possibilities, even the ones that just seem, crazy, and just like, no, that can't possibly be, because it's, I think I can say this with near certainty, that everything that we think we know today was at some point somebody's guess, and it could be a wild guess, right? I mean, relative to what is known, right? It could be a wild guess, that wild guess that put the sun in the center of the solar system and the Earth as one of the planets going around it. That was crazy, right? That was totally crazy. I mean, and people got very, very upset about all of this, right? Uh, you know, it was that kind of talking was actually suppressed for quite a while, right? Aristarchus, was it Aristarchus or was it? Yeah, I think it was Aristarchus. Back what 2,500 years ago, maybe a little bit more, maybe a little bit less, was thinking about a sun-centered solar system, and you know, that information was knocked out. It was suppressed. It was basically forgotten, right, for 2,000 years until you know, people like Copernicus and you know, his contemporaries, at least some of them, started. It was like, you know, what was this Aristarchus dude talking about? You know, and is there any validity to this crazy, you know, backwards notion that the sun is in the center when it's very, very obvious, and you know, we can make observations and they fit models that we've made. It seems very, very, very clear that the sun is going around the Earth, right? I mean, it just seems obvious, and so my point there is, right, is that you know, keep an open mind about things. You know, even things that just are just a little on the far side, right? And you know, reserve judgment. Run what you hear and what you measure and what you think through the scientific method, and you know, come up with ways. It's like, okay, well, if this is true, right, then I should be able to observe, you know, A, B, C, D, and E, and you know, that feeds back into itself, and you get progress that way. So those are my three things: curiosity, skepticism, open-mindedness, and I think with those three tools, you know, finely tuned, you know, used well, as a scientist, you'll go really, really far, and you know, as a person, you will too, because you won't fall for things. You know, one of the things that really actually even early on turned me off to like news media, right, was when, and this is true even today, for sure today, when I hear some kind of astronomical news story in the media, it's usually not wrong, but it's usually not quite right. They've misunderstood, they've misinterpreted something, and they're reporting it that way, which I mean, fundamentally makes what they're saying wrong. It's not totally wrong, it's just not quite right. And so, you know, as a skeptic, right, as a rabid skeptic, my reaction is, okay, if they're kind of misunderstanding, you know, topics that I understand really, really well, then are they doing the same thing with these other stories that maybe I don't understand quite as well? Are they misinterpreting things too? And I think the answer is yes. right? So now that doesn't mean that you should ignore them, or you should gather as much data as you can. That's being open-minded, but look at it really, really hard, right? Don't buy into anything. Don't buy into anything. Yeah, the history of astronomy is a pretty interesting one. And Atta, you may be particularly interested in what I'm going to say now, and that is, one of the problems with the history of astronomy, and unfortunately, history in general, is that it has ignored half the population of the planet, and that is all the women. So I encourage you, when you're going through, looking at the history of astronomy, look and see how many guys there are, and look and see how many girls there are, and you may have to do your own research, but you will find that that um, it turns out, surprise, surprise, that women contributed uh, at least equally to men in terms of work, in terms of coming up with new ideas, all of that. Yeah, it's extremely cool. The history of astronomy it's one can say, again, I think I can say this with pretty good certainty, and that is that astronomy is really the oldest science we have, mainly because uh, it's so multi-level, right? I mean, all you need to do is look up and observe, and there aren't too many sciences that allow for that. Even in physics, you usually need some kind of object. You need some kind of like apparatus, uh, all that. But with astronomy, at one level, and I'm not going to characterize it as the simplest one. It's just at one level. Um, Going outside at night and looking up and making observations, and it doesn't get, uh, that doesn't require anything at all, right? At least in terms of stuff. Um, yeah, the Parker Solar Probe is going to touch that sun for sure. Yeah, it's that kind of thing, right? And unfortunately, NASA is pushing that term. But yeah, that's an example, right, of the media, repeating things that it's not it's not quite right. It's not quite right. So, but you know, getting into the details of that is just going to confuse people who don't know, right? And I mean, it's not as if they're stupid or anything. It's just, you know, if you don't know, if you don't have a background, you don't have any kind of context, and so any kind of explanation is going to go so far above your head, right, that you can't reach it, and that's no fun, right? I like topics that are definitely above my head, right? But I have to be able to reach them. I have to be able to reach up and grab some of them, at least. Uh, so yeah, but Tom, that's a perfect example. Um, yeah, Atta, I'm not sure. I'm not sure if they're sophisticated enough to be able to change the story around in order to make it an actual lie. Um, that that takes a knowledge of the subject that I don't think they have.
Now, Cosmic,
Yeah.
if the Parker Solar was able to touch the sun, would it cause a major destruction with the sun, or is it going to be all right?
Well, one of the problems with the concept of touching the sun is that, at least our current understanding is that the sun has no surface. There is nothing to touch. So right there, uh, it, it's not it's not it's not wrong, but it's not right, because there is nothing to touch. So saying that is it's like a non sequitur, right? It just doesn't make any sense. Uh, there are different regions of the sun, um, but you know, at least until you get very 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 deep into the sun, it's not a very dense place. I mean, it's a plasma, for the most part, and you've got to go relatively deep. I mean, I would say past to the photosphere, in order to start, actually feeling anything that would sort of appear to be like hard stuff. So, but yeah, they are going to be getting really, really close to the sun. I think they're going to be getting within, they said like 4 million miles, which is roughly 4% of the distance between the Earth and the sun. So that is really close. All right, that is really, really, really close. It's going to be nice and hot. Um, yeah, 4 million miles. Um, so yeah, but again, it's sort of like, well, 4 million miles from what? If there is no surface, is that 4 million miles from the center? That would make sense. So that's probably what it is. But that's really the only reference point that you can use in terms of the sun. Is just the center, the physical center of it, because everything else is either not accessible. Um, I think, Atta, in this context, I think we're talking 4 million. 4 million. I recognize the terminology that you bring up, but I think that's used in a different context, and that context is escaping me now. It's not astronomical. so yeah.
No.
But for sure, the Parker Solar Probe is going to do amazing things. I mean, I'm actually really, really excited about the Venus flybys. They're going to be going by Venus like 7 times or so. Sort of fine tuning its orbit, going around the sun, and those Venus flybys are going to be pretty interesting, right? So, cheers to PSP.
Now, 4 million miles, that's not really touching the sun at all, or is it still touching the sun?
Well, my guess is that is from the center of the sun, because the sun is something like, what's the radius of the sun? Let's go find out here. I'll share my screen. We can just do that really, really quick. We'll go over here. Whoop. Over here. Definitely want to look at the Pluto occultation today, but let's get. I want to say it's something like 200,000 miles, but let's find out. Sun. Oh, sun size. Okay, all right. So 432,000 miles from the center to some location, probably like the photosphere. That's sort of, you know, considered sort of the surface of the sun. So that's like 10 times. Yeah, and actually, you know, now that I'm thinking about that, they actually mentioned that it's going to be getting to about 9 or 10 solar radii out, and that makes sense, right? I mean, if this was 10, you multiply it, you put a 0 on the end, and that's 4 million miles. So yeah, 10 solar radii or so.
Not to touch the sun, but not much.
Yeah, you know, it's closer than we've ever gotten, for sure. Okay, but let's look at SOHO, right? Because SOHO has these images of the sun and its surrounding area, right? Okay, so here I believe is the size of the sun, right? So here's one radius. Okay, it's about the width of my mouse pointer. Okay, so let's go out 10 of those, right? So if that's the surface, okay, here's 1, here's 2, here's 3, here's 4, 5, 6, 7, 8, 9, 10. Something like that, right, is 10 solar radii. And that's as close as it's going to get, right? It's not going to get in here. It's going to be, I guess I would say, you know, in this image, maybe like halfway out. All right, so it's going to get way, way, way out here. So yes, it's going to, you know, go through the corona, right? And it's going to be nice and close, and it's going to be nice and toasty. But that's as close as it's going to get. And they're actually only going to be close like that for, I want to say a couple hours, because this probe is going to be moving, I believe, faster than any spacecraft we've ever built. But it's only going to be moving that fast when it's really, really close to the sun. You guys remember Star Trek 4, The Voyage Home? Yeah. They used the sun to slingshot, you know. So as they were coming in to the sun, they had their engines up full throttle, right? But they used the gravity of the sun to accelerate even more, and at least according to, you know, the calculations, they could get themselves into time warp that way, you know, by slingshotting around the sun. Well, Parker Solar Probe is also going to slingshot around the sun, and yeah, I think it's going to be just screaming fast. I mean, really, really fast. Did I hear something like 400,000 kilometers per hour? All right, let's follow our noses here. This is what this live stream is all about. So let's just. Oh, I grabbed the wrong one. Sorry. Let's look at the Parker Solar Probe really quick and just see if it will give us an indication of the fastest speed. And maybe somebody in the chat, Tom or Uncle Bill, Atta, if you know that speed offhand, that'd be cool. You can yell it out, and we can confirm it. But let's see if we can do a quick look here and see No, let's go to this one. Whoop, dang it. Let's go this one. This looks like the main site here. Let's see, spacecraft, extreme environment, news center. Let's look the mission, journey to the sun. Well, let's see, extreme environment. I'll bet you, I mean, because it's an extreme amount of motion, for sure. So 3.83 million miles is what they're saying. But I want to know how fast they're moving. Well, let's do this. Google is our friend. Velocity. Okay, I guess Wikipedia. Okay, yeah, I saw it there for just a second. Yeah, so we'll approach to within 8.86 solar radii, and we'll travel at closest approach 430,000 miles an hour. So yeah, that's basically one solar radius. Solar diameter or solar radius? Oh shoot! I'll bet you that's a diameter. Oh, that's a radius. That's a radius. Okay. Well, okay, let's go forward here. So, yeah, it'll move the diameter of the sun in 2 hours. So it zips in really fast and then flings itself back out to about the orbit of Venus, and that's why it's doing all these. Well, it's one of the reasons, of course, why it's encountering Venus so many times. All right, well, cool. Let me see what else is in the chat here. Yeah, see, Tom got it. Tom got it. Cool. Star Trek, the original series, used the sun's gravity to time travel? No, wait a minute, Tom. Wait a minute. I know my original series episodes pretty well. Oh man, I can't remember one that did that. If you can get Tom, since you're on a roll, get the name of the episode. That one that you think they slingshot around the sun. Yeah. Oh no, wait a minute. There was one. Oh, maybe not. I'm not remembering. It's awful. Okay, let's sort of move on here. So the minor planet, the trans-Neptunian object, the Kuiper Belt object named Pluto, passed in front of a star the other day, and that occultation was observed. Now, I haven't really investigated this much, so let's. The only investigating that I did was I noticed a couple of posts on cloudynights.com. So let's start there, and then we can go from there. I'm going to share my screen again. I'll hide that. I'm going to go to infinity. Woo, look at that. All right, enough of that. Let's go over here, and I'm probably not going to find it that way. Let's do it this way. Let's look for the word Pluto. So if you're not aware of Cloudy Nights yet, take a look. Take a look, because it's a great site. So this fellow here, D. Bruns, he was using a C11. That's an 11-inch celestron. I think this is the camera here, if I remember right. So he did 2-second exposures, a series of 2-second exposures, just, you know, bang, 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 bang. You know, this was a relatively long occultation, so you know, something like that can actually be done, right? I mean, if you have a 1-second long occultation, but you take a 2-second exposure, you're not going to see anything. But if you have a, you know, several minute long occultation, then you can get away with taking 2-second exposures, and so that's what he did, and I thought of doing that too, but yeah, you know, yeah, it's sort of an opportunity lost. That's how it goes. Anyway, so he collected his data and he actually posted it. He posted a little light curve. So let's take a look at that. We'll do it over here. So there it is. So this, as he says here, is a very preliminary light curve, just showing that, you know, there was a dimming of this star, and it was pretty deep, right? This is a sort of a relative intensity. He probably, you know, figured out an average brightness, right, when the star isn't being occulted, and then so that's why this ratio is around 1 here. And then, as you can see, it dims by 80%, right? It gets really, really, really dark, and then comes back up. Now, Pluto, I think, is like 14, was about 14.6, magnitude 14.6, and this star was magnitude 13. So I'm wondering if a magnitude 14.6 object is 80% fainter than a 13th magnitude. I'm going to have to think about that math a little bit. So let's move on. So this down here is probably just showing the minute. It's not showing the hour. It's just showing, you know, the minute. I think the hour was, at least in UTC, was 5 hours. So this would be 5 hours, 29 and a half minutes, 5 hours, 30 minutes, 31, 32, 33. So for this observer, at least, right, mid-eclipse was somewhere around 5:32 and a quarter, right? So what's a quarter of a minute? 0.25 times 60, 15 seconds, right? So at 5:32:15 is where he sort of saw, you know, the dimmest thing. But as you can see, it's not an abrupt drop, right? I mean, it doesn't go from on to off, and then off, and then abruptly on, right? It does this, right? It does this, and it does that for 2 reasons. And I'm not quite sure which one would have more of an effect, but there are at least 2 things going on here. One is diffraction, right? So you know, you're putting an extended object, an extended disk, Pluto, in front of what is essentially a point source. And so along that edge of that disk, you're going to have diffraction. So that accounts for a little bit of this curve. The other thing that accounts for a little bit of this curve is the atmosphere of Pluto itself. So both of those things are happening. My guess, moderately educated guess, I guess, is that this part here, the early part and the late part, is probably diffraction, and this part here is probably part of the atmosphere. Just a guess. Now, I don't know if you see it or not, but there's a little brightening. There's a brightening here. Well, that's a real effect, and let's go over to here. Is it this one? Is it this one? No. Where am I? There was a maybe it was. I want to get the terminology right. Okay, so they call it essential flash. Essential flash, and that's a. I guess what that is that's a sort of a focusing of light by the atmosphere of Pluto. It's acting like a little lens, and so you get this brightening effect right in the middle of the occultation. It's when all the starlight, is hitting the other side of Pluto, and sort of being spread out by the atmosphere, and we can actually see that. And yeah, I guess they just call it essential flash. Essential flash. So yeah, I'll have to look up the explanation for that a little bit more, because I'm probably a little bit incomplete about that. But this is a nice light curve, right? I mean, it's noisy, right? It's noisy, but that's pretty flat, and that's pretty flat. So, you've got to take into account that noise doesn't go away during the event. So this is noisy too. It doesn't look quite as noisy. I can't account for that, but it doesn't. Maybe what we're seeing here is actually scintillation of the star. The star is twinkling because it's a point source, but extended objects like Pluto, right, don't twinkle as much. So, I'm thinking out loud here, but I'm sort of thinking that, what we're seeing here, right, is Pluto. This is Pluto. The light from Pluto. That's why this isn't going all the way down to zero, because we're actually seeing, well, he is, he's actually seeing Pluto as well. And it is an extended object, and it's not going to twinkle as much. So that's just a wild guess. But, this being as noisy as it is, and this not being noisy, and then again here, that's my guess. That's my guess. So, you can sort of see just from this kind of plot, you can gather all kinds of really, really cool information. So, one of the ways you can go off with this data now is create a model, right? Create a model that will also create a light curve. And you create a light curve and you compare it to this. And it's like, well, how close is it? You know, how good of a fit is it? Well, if it's not a good fit, you can change the parameters in your model and run it again and see if it fits. And you do this over and over and over again in a iterative way, right? So you start with a guess. It's like, oh, no, you know, that's wrong. I'm going to change the little thing, run it again. Okay, closer, but still I've got to do, you know, I'll change this. And you sort of hone in on it. And in the end, right, if your model light curve fits this, you know, fits the actual light curve really, really, really well, you may come to a conclusion that the parameters that make up your model, you know, might be correct. And those parameters might be, you know, size of Pluto, thickness of the atmosphere, velocity relative to the observer. With the scintillation thing, it's like, you know, how much does a 13th magnitude star scintillate? You know, is that what you would see? And you know, does Pluto not scintillate that much? All kinds of things, all kinds of cool stuff here. I don't think he said in his post if he used any kind of filters or anything. But yeah, I guess this is just raw, uncalibrated data. So, you know, again, the skeptic in me is like, okay, well, if it's not calibrated, then as nice as this looks, it's not right yet. It's not quite right. All of this could you know, potentially go away when you calibrate. You know, this shape of this curve might completely change. The scintillation here might completely go away. I don't know. Not taking into account all the instrumental things. You know, you got to be skeptical of this kind of data. Looks pretty good though. Let's see. So yeah, somebody in Tucson near me commented that they missed it too. Yeah. Yeah. So let's I thought, where is, let's go here. Is it here? No. Is that it? No, that's not it. Let's just get me an email. Oh, here we go. No, that's not what I wanted either. Cancel that. Results. I thought somewhere there was a. Oh, I posted it. Yeah, I wonder. Let's go over to my Discord server. Discord. And we will ching. Dun, 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 dun.
Hey,
Yes, Bobby.
hey, you you still got time and stuff. I can share my system and I can show you what some of the SDR receivers that you probably might be able to get Now, I'm not sure you might get one at your pricing range, but it will come close.
Okay, cool. Let's do that afterwards for sure.
Yeah.
Cool. All right, let me see if I can find the link. Here we go. Is that it? There's this one and there's this one. Let's look at this one first. I just want to see if there's any, if anybody's posted any data, any reports. Okay, I don't see anything there. Recall, there's a report link. The feed, network page. I'm not going to, I'm not gonna spend too much time looking. Post-event details, report your observations. Event reporting status page. To view reports from teams throughout the network, check out the event reporting status page. Okay, so there's still 24 sites that need to file a report. So detector won't be working in time for Pluto. Too smoky in the Okanagan. No unavailable. Heavy wildfire smoke. This network is all in the western United States, and we're having some exciting fires around. So heavy smoke. Selected to observe for 8 minutes around the event time. Everything went well. Recorded at 32x. Target was continuously visible. So that's up in Washington State, which is pretty far outside of the range. If you look at the map here, I don't really like that map too much. Here we go. I sort of like this map the best. See, so Washington State, in fact, the town of George, Washington is right about there. So, yeah, at least according to this map, you wouldn't really expect to see the occultation, right? This is the center of the occultation. This is half light. So you see the star dim by a factor of a half. This lighter purple one is dimming by 1%. So that observer was probably outside of that. So the fact that they didn't see the event, yep, makes sense. Field completely obscured by smoke. Huh, okay. Weathered out. Bend, Oregon, attempted but no data. Although there was some smoke in the air, it was not too bad. We got in the field and we're confident that we had the right field. Yeah, see, I mean, one of the things that I learned early on is that you do not try to find your target, especially if it's a faint one. You do not try to find your target, right before the event. You try to find your target days in advance. So when the night comes, when the time comes, you can set up, point your scope with no delay at all. So but they had to be confident, right? Because they had to hurry. Let's see. So all systems were go until 4 minutes before the recording time. The camera blinked on and off, displayed a plaid pattern. They went plaid. We inspected all of the cables and everything seemed to be properly connected. The communication between the camera and the computer was suspected to be the problem. We also suspected a power issue. We disconnected we discovered a burnt fuse. Wow. So once the fuse was replaced, they were hopeful with 1 minute to go. Then the cord from the camera popped, bubbled, and smoked. Oh, that's awful. I'm laughing with them, not at them. So we quickly unplugged everything to stop a possible electrical fire. Wow. Well, you know, that's Bend, Oregon for you. Okay, so North Lake, is that Oregon? I'm not sure. Data collected. We had a problem with our power source, but after switching to another power pack, we got things up and running. Successful recording. We started a few seconds early and ended a few seconds late due to the telescope shaking a bit as we walked on the deck. Yes. Yes. If you want to observe and be relatively stable, put it on the ground. Put it on the ground. And even on the ground, you can't be stomping around, right? You're going to shake the ground a little bit. So Klamath Falls, atmospheric dimming, cool. Data collected, no events seen. I don't know where Tula Lake is. Not quite sure. Let's see. Okay. Cedarville, not quite sure what that is or where that is either. Attempted, but no data. Because of the clouds, we almost didn't set up. So, well, they set up at 4:45, which was like 45 minutes before the event, but they had trouble doing an alignment. There wasn't enough time to solve the issue before the observation window can't come and gone. Oh, that's awful. So in Susanville, they apparently got some good data. Cool. I'm going to check the chat really quick. In fact, I can have the chat sort of over here.
My show's on there.
Cool. Okay. Did Tom actually? Oh yes, Gary 7. Yes, you are right. You are right. Yeah, I think it's called Gary 7. It's the alien dude that had to go back in time to one of the rocket launches to either, yeah, he had to make it so that it would self-destruct, but yeah, for some reason the Enterprise guys didn't know whether he was supposed to destroy it or not. So yeah, okay, cool. Yes. And Terry Garr was actually really good in that too. But yeah, I actually I watched a Twilight Zone episode, one of the old ones, a couple of nights ago that had the main character there was the guy who played Gary 7 in that Star Trek episode. Yeah, okay, Tom. Yep, I stand corrected. You're exactly right, and I definitely remember that that episode now. Yeah. Well, you know, I don't mind having to catch up a little bit. So not a problem. Not a problem. Yeah, I never got into Babylon 5. I tried, and there were people who absolutely loved it, and then there were people who were like, eh. And I guess I was one of those eh. Never got into Firefly, not really. I got into the first season or two of Galactica, but then it turned into a soap opera and it wasn't interesting anymore. Never really got into Stargate either. I like the movie. I like the concept. Actually, Heinlein wrote the book on Stargate. He wrote a book called Tunnel in the Sky, and that is a Stargate. Let's see. Yeah, take over the chat with sci-fi anytime you want. I am there. Didn't scroll up enough. Oh, man. Oh, wow. Okay. Yeah. Okay, cool. I am caught up for the most part. So let's sort of look at a few others here of these reports. There's only a few more here. So full overcast, totally cloud. We were on the correct star field, but clouded out 10 minutes before. Oh, man. Clouds. Let's see. From Henderson, I guess that's Nevada. Target field located. Scope started to lag with tracking, and we discovered the battery was rapidly dying. Not the first time this has happened. Oh man, so yeah, they lost that one. You don't need a sky tracker to observe occultations, though. It's a lot easier, right, if your target isn't moving in the field of view. But if you're a good observer, you can do that. So Boulder City, which is actually in Arizona, great night for observations, recorded something. So cool. Very cool. CPSLO, I don't know where that is. Tracking again. Tracking problems. Kingman, that's also in Arizona. We are not sure what is meant by light curve analysis. Oh man, and you've got these people collecting data for you? Okay. I should switch to live chat instead of top chat. Oh. Okay. What, Uncle Bill? You are the man. What's the difference there? Okay, so in Laughlin, Bullhead City, being a school night, short notice, no students were able to attend. The sky was clear, and I feel we recorded data for the whole event. I had plenty of time to readjust the scope, and really confident of being on the correct field. For someone who saw that field of view, that is a really, really, really easily recognizable field of view. So yeah, hopefully they were. Sprinklers came on just about recording time. That's funny. Yeah, rain. Wildwood. I'm not quite sure where Wildwood is. Maybe in Arizona. I'm not sure. Just just down the street. Arcturus and Antares were both visible at that time, and they served as our 2-star alignment targets. Good. By the time we were set up, cloud cover had moved in, obscuring all star candidates for alignment. From 9:30 to 10:15, we tried to catch a glimpse of a star we could use for alignment. They say that they collected data, but that indicates something else. Wildwood is in New Jersey. Yeah, they have a map. Is this it? They have a map of all the locations of the observers. It's not here. Maybe what I just... No, that's just that one. There's a map of where all these things are. I thought it was all. Let's see. No, that's not it. Now they had a map somewhere of all the different locations. Download map. That's not going to help. Sky map. Network page. This is a little bit of diversion here. Observations, report form, observation log sheet, protocol, sign up. Yeah, maybe not. Here's the list. Yeah, they had a really nice map. There it is. There it is. So I'm not quite sure where. I don't even know which one we were looking at now. Which one were we looking at? Wildwood. Can we see Wildwood anywhere here? Wildwood. Wildwood. I'm not even seeing it on this map. It's got to be there somewhere, though, you would think. But I'm not seeing it. All right, anyway. And Yuma. Well, Yuma was definitely clear. I know about that. I mentioned that, I think. If I were to drive over to Yuma, I would have seen it. But the RCA to USB adapter has exposed wires. We were able to tape it and get it functioning long enough for this event, but we do need a new one. Other than that, ideal conditions. Man, so if it wasn't clouds, it was equipment problems. They had fire and smoke and clouds. Crazy. But yeah, I guess this is the whole network that they have. So yeah, it just goes down the west coast there a little bit. And of course, I'm over here. And this was this the center line? I don't think this was the center line. I don't know what exactly that is. Light solid line. I just see a dark solid line. Track limits. Yeah, I don't know. Anyway, so that looks like it was a pretty interesting event, and it looks like it was observed, at least. I'm guessing that more people actually observed this. Anyway, yeah, here's the field of view. These 4 stars here are really easy to see. These 2 stars are easy to see. And then there's, that was the star there that was occulted. You can see that one and that one. So now there's another one here. I wasn't able to see that, but I was definitely able to see that guy and these. But yeah, having this kind of pattern, super, super easy to find that. Yeah, super easy. Here's another example of that too. Just a wider field. Yeah. And actually this here was extremely helpful, you know, to have this bright star and then these three around it. That made a very recognizable pattern. And then looking south, you find this pattern and bang, right there. All right, well, cool. I'm noticing that it's 3:06 UTC. Let's I'm going to stop sharing, and I'm going to pop up my chat again really, really quick. Okay, yeah, Uncle Bill, that may not yet sort of apply to this chat, but yeah, hopefully at some point it will, and I think that Google is now going to remember that I'm going to have that set. So very, very cool. All right, well, I think for today I'm going to get out of here. So thanks everybody for coming in. Make sure to smash the thumbs up if you so desire. And for those of you who are watching this later, howdy. Glad you could come in. Make sure to subscribe if you haven't, and spread the word. Spread the word. We're, you know, this is a growing circle of friends, and there's enough room for everyone. So definitely.
You want to set the SDRs right click, or do you want to do it like on the post show?
Let's do it on the post. Cool. All right. I'm going to get out of here for now. So I will see you all. It's possible that tomorrow night's live stream will be canceled. It's either, well, it could be tomorrow night or tomorrow. It could be the next day, or it could be neither. Depends on clouds. So, yeah, it's going to be sort of short notice. I'm not going to make a decision until around 1 hour UTC. So, yeah, it's going to be a short notice kind of a thing if I cancel. But I will definitely let you know in the Discord, and I'll probably tweet it too. And maybe I'll make a short little video too. You know, I'll do one outside or something. So, yeah, there's a possibility that the live stream either isn't going to happen tomorrow or the next day. Not both, right? I mean, I'll be here. And of course, if it's cloudy, then the live stream will go on because, yeah, clouds don't affect this live stream in any way. Many other things do, but definitely not clouds. All right, you guys, take care, and I will see you all on the spin. Bye.